In part 2 of this series, we will attempt to visualize the effects of flow on air bubbles trapped within a clear blood analog fluid. In the first view, the camera is turned on its side and air is slowly injected into a half-inch tubing at low flow using a 10 cc syringe with 25 gauge needle. The bubble size being generated is approximately 3,500 microns. Here we see buoyancy working in opposition to viscous drag as bubbles slip from side to side in the fluid while being pulled downward in the tubing. Note that the side-to-side movement of each bubble seems random with no apparent set pattern. In this video clip, the flow rate is increased while air is injected using the same method. Although the increased flow is expected to cause a decrease in the bubble size produced, notice how the buoyancy force is immediately less visible. Here we see more of a pattern to what could be described as an exaggerated side-to-side movement, as the bubbles captured in the higher viscous drag pass through the turbulence being generated at the connector outlet. To fully appreciate this, focus on the area highlighted by the arrow to observe some of the bubbles actually being pulled back by the turbulence toward the connector. In this clip, air injections are again repeated while the flow rate is increased further. Now the bubble tracings are less erratic and follow a more uniform path as the turbulent flare from the connector is stretched out, giving way to a straighter, more laminar flow pattern. In this view, we see a large uniform bolus of air, which remains stable in a base flow of 1.2 liters per minute. As the flow rate is slowly increased, the bolus first starts to deform and stretch out, and then starts to break down as the flow rate exceeds 1.5 liters per minute. In the final sequence, the effects of increasing flow on a wide range of bubble sizes is demonstrated. Notice how the size of the bubbles passing by increases with time, which corresponds to an increase in flow. Finally, watch the large 2,300 micron bubble highlighted by the arrow as it first changes shape and then becomes detached from the wall before a uniform bolus in excess of 13,000 microns passes down the half-inch tubing at 3.1 liters per minute.